The U.S. Space Force just awarded Rocket Lab contracts worth hundreds of millions of dollars for critical national security missions, choosing them over giants like Blue Origin. They've locked down deals including a massive $515 million satellite contract and earned a spot in the $5.6 billion NSSL Phase 3 program. How is a small launch company beating out the heavyweights? Here's the kicker. Rocket Lab's recent $14.4 million Electron launch for Space Force earned nearly as much as Blue Origin's $20 million Mars mission with New Glenn. What's Rocket Lab's solution that's disrupting the entire market? Let's rewind to November 2024. The entire space community was watching Blue Origin's New Glenn rocket make history. This massive heavy-lift vehicle launched on its second flight, carrying 2 NASA satellites all the way to Mars to study the planet's magnetosphere. The booster came down for a picture-perfect landing on a drone ship at sea, looking like something straight out of a science fiction movie. Jeff Bezos had every right to celebrate. But here's what nobody talked about. Blue Origin only earned about $20 million for that spectacular Mars mission. Why so little for such an impressive feat? The answer reveals everything about where the real money is in space right now. This was essentially a discounted flight, with NASA helping fast-track New Glenn's certification. Blue Origin needed the flight credentials more than the revenue. They were building their reputation, not their bank account. Now contrast that with what happened on December 18th, 2025. Rocket Lab opened the launch window for their Electron rocket from Wallops Island, Virginia. This wasn't a Mars mission. This wasn't deep space exploration. This was a U.S. Space Force mission called Don't Be Such a Square, carrying just 4 experimental disc-shaped satellites. The payload? Flat test satellites designed to operate in very low Earth orbit. Nothing glamorous, nothing headline-grabbing. Yet, this single Electron launch was worth $14.4 million. Think about that for a second. A tiny rocket flying a routine orbital mission earned only $5.6 million less than a Mars-bound, heavy-lift rocket. What does that tell you about where the market is really headed? Here's what's actually happening. The U.S. Space Force is being heavily funded right now as national security becomes the top priority. Meanwhile, NASA is dealing with budget constraints and has to count every dollar. The Space Force doesn't need flashy Mars missions. They need reliable, responsive launches that can deploy critical assets exactly when and where they need them. And that's precisely what Rocket Lab delivers. But let's dig deeper into this particular mission, because it reveals Rocket Lab's strategic advantage. Those flat, disc-shaped satellites, stacked like pancakes inside the payload fairing, were developed by the Aerospace Corporation with NASA funding support. Each disc is about 1 meter in diameter, thin and wide, giving them plenty of surface area for solar panels and antennas. Thanks to their unique shape, they experience lower atmospheric drag, making them ideal for long-term operations in very low Earth orbit, below 300 kilometers, without rapidly losing altitude. They're equipped with electric propulsion, allowing precise orbital maneuvering and adjustments. For this mission, Electron inserted the payloads into a circular orbit at around 550 kilometers. From there, the satellites will test orbital maneuvering, deployment systems, and controlled orbit changes. This is exactly the kind of rapid technology demonstration the Space Force needs. Can Blue Origin's massive New Glenn do this kind of mission? Technically, yes, but it would be like using a sledgehammer to hang a picture frame. The $14.4 million contract was signed back in 2024 under the U.S. Space Force's Space Test Program, which focuses on testing emerging technologies with potential military applications. And here's another milestone that matters. This flight marked Electron's 20th launch in 2025, setting a new annual record for Rocket Lab. 20 dedicated launches in a single year for a small-lift rocket. That's consistency. That's reliability. That's exactly what military customers demand. Now, I know what you're thinking. 20 launches sounds impressive until you compare it to SpaceX. Kiko Don TV, SpaceX's vice president of launch, recently celebrated achieving 165 Falcon 9 launches in 2025. That's 165 medium-lift missions in a single year. Compared to that, Rocket Lab's 20 launches look modest. But here's the critical difference. Falcon 9 rideshare missions are cheap, but they come with long wait times and shared orbits. You're packed in with dozens of other payloads, heading to whatever orbit SpaceX decides. For commercial customers trying to save money, that's fine. For the military running time-sensitive operations, that's a deal breaker. And that's still more than Blue Origin has managed. Despite having 2 rockets in their arsenal, New Shepard and New Glenn, Blue Origin still hasn't launched a single satellite for a paying customer. They're preparing for a historic milestone with New Shepard mission NS-37, potentially making history as the first spaceflight carrying a person in a wheelchair. That's meaningful from a human perspective and genuinely important for accessibility in aerospace. But let's be honest, it's not orbital, it's not operational, and it's not revenue-generating in the way that matters for competing in the commercial launch market. So, what's Rocket Lab's real secret weapon? It's not just about Electron, it's about the entire ecosystem they've built. Rocket Lab has been on-ramped into NSSL Phase 3, Lane 1, the National Security Space Launch Phase 3 program. This is a massive framework worth up to $5.6 billion shared among selected providers. Under this program, Rocket Lab plans to use Neutron, their medium-lift rocket, currently in final development, to compete for major national security missions starting in fiscal year 2026. They're not just staying in the small lift corner, they're expanding upward while maintaining their dominance below. But wait, there's more. Last year, Rocket Lab landed a massive $515 million contract with the Space Development Agency under the U.S. Space Force. In this deal, Rocket Lab acts as the prime contractor responsible for designing, building, and operating 18 military satellites. These satellites will form part of Tranche 2, Transport Layer Beta, a constellation focused on military communications and threat detection, supporting the Pentagon's next-generation space architecture. Read that again? Rocket Lab isn't just launching rockets anymore. They're building the satellites, launching them, and operating them. This is full-stack space capability, and it's exactly what the military wants. Why deal with multiple contractors when one company can handle everything from design to deployment? This vertical integration is backed by something Rocket Lab excels at: satellite manufacturing. They've built out an entire family of spacecraft buses designed specifically for mass production. Right now, they're sitting on a backlog of more than 40 satellites already under construction. Compare that to Blue Origin, who's still trying to prove they can launch reliably. Rocket Lab is already building the payloads and launching them on their own rockets. That's a business model Blue Origin can't compete with right now. Let's talk about Electron itself, because this rocket is the foundation of everything. Electron is a compact, highly efficient, small-lift rocket perfectly tuned for the small-sat market. It stands about 18 meters tall with a 1.2-meter diameter. The first stage is powered by 9 3D-printed Rutherford engines, while the second stage uses a single vacuum-optimized Rutherford. Electron can deliver up to around 300 kilograms to low Earth orbit with extremely precise orbital insertion. And that precision is exactly why customers keep coming back. A dedicated Electron launch typically costs around $7.5 to $15 million. Yes, that's more expensive than SpaceX's rideshare missions. But in return, customers get something Falcon 9 simply cannot offer: their own orbit, flexible launch timing, and no waiting around or sharing risk with dozens of other payloads. Here's what really sets Electron apart: responsiveness. Fast launches, short turnaround times, sometimes just days between flights, and a fully dedicated mission profile. That's exactly what the military wants for rapid technology demonstrations or urgent deployments. SpaceX completely dominates medium and heavy lift, no question. Their rideshare is cheap, but it comes with compromises. Blue Origin is going all in on massive heavy lift with New Glenn, but using that for small satellites would be pure overkill, and they still don't offer a regular lightweight rideshare service anyway. That's the gap Rocket Lab has exploited brilliantly. While Rocket Lab's future is starting to look bright, the outlook for Blue Origin in the heavy lift launch market is shaping up to be a brutal fight. And that fight is directly against SpaceX's Starship. New Glenn looks solid on paper, over 90 meters tall, a reusable booster, clean landings, and now moving through certification to compete for billion-dollar Space Force contracts. But here's the uncomfortable truth: how do you compete when your opponent is playing a completely different game? SpaceX is closing in on true full reusability, not just the booster but the ship itself, returning to Mechazilla and flying again and again. If Starship scales the way SpaceX expects, launch costs could drop to around $10 to $20 million per flight. New Glenn can currently only reuse the booster. The upper stage is still expendable in early flights, and estimated launch costs remain much higher, with some estimates putting them in the $100 to $200 million range initially, even though Blue Origin says those numbers will come down over time. And then there's raw capability. Starship can deliver roughly 150 to 200 tons to low Earth orbit in a fully reusable configuration. New Glenn is closer to 45 tons. That's almost 5 times less capacity than its main competitor. Blue Origin is trying. They have NSSL Phase 3 contracts, NASA as a customer, and some genuinely impressive landings. But if they want to truly challenge SpaceX in heavy lift, they need to prove 3 things fast: lower costs, higher launch cadence, and full reusability. Otherwise, New Glenn risks permanently becoming the second-best option. So here's the bottom line: Rocket Lab didn't try to outmuscle the giants. They found the gap nobody else was filling and owned it completely. While Blue Origin chases SpaceX in the heavy lift arena, Rocket Lab built an entire business model around what the Space Force actually needs right now: responsive launches, dedicated orbits, rapid deployment, and full-stack capability from satellite manufacturing to operations. That $515 million satellite contract and their spot in the $5.6 billion NSSL Phase 3 program prove they're not just surviving, they're thriving. Blue Origin has impressive technology, no doubt. Those perfect booster landings are beautiful. But beautiful doesn't win contracts. Reliability, responsiveness, and vertical integration do. And that's exactly what Rocket Lab delivers every single time. Now, before we wrap up, here's one more bombshell. On December 17, 2025, the U.S. Senate confirmed Jared Isaacman as the new NASA administrator with a 67 to 30 vote. For the first time in decades, NASA is being led by someone from the private sector, not a career government official. Isaacman, the billionaire entrepreneur who flew on SpaceX's Inspiration 4 mission, now controls NASA's entire direction. What does this mean for the future of space exploration? That's a story for another video. What do you think? Can Blue Origin turn things around, or has Rocket Lab already locked down the market they're targeting? Drop your thoughts in the comments below. If this breakdown gave you a new perspective on the space industry, smash that like button and share this with anyone who still thinks rocket size determines success. And don't forget to subscribe to New Space Review for more deep dives into what's really happening in space. We'll see you in the next one.